We are going to begin our study of Chapter 7 today on Understanding Weather with Lesson 1A. And if you'll notice, there are 4 lessons altogether, but I've divided 1 and 3 into 2 parts. So it'll make it a total of 6 lessons. We'll actually be on this chapter for at least a month. All right, and it's not noted here, but the songs are at the beginning as always. So 7.1a, our lesson today is water in the air. We have 3 objectives. Explain how water moves through the water cycle. Describe how relative humidity is affected by temperature and levels of water vapor. And describe the relationship between dew point and condensation. You're going to come back and watch the brain pop. Make sure you log in through ClassLink. You're going to watch the movie Weather and then complete that quiz as well. So the water cycle, and this should not be new information, this should be a review. The condition of the atmosphere is affected by the amount of water that is in the air. Water in liquid, solid, and in a gas state, it's constantly being recycled through the water cycle. Henceforth, the water cycle. So the water cycle is the continuous movement of water from sources on Earth's surface into the air, over and onto land, into the ground, and then back to the surface again. So you're going to go back and watch the study jam on water cycle, and here's another brain pop that you're going to watch on water cycle and complete that quiz as well. Remember, I'm randomly picking brain pops to take grades for. So here's the picture form of what the water cycle looks like. So you have precipitation that of course occurs when rain, snow, sleet, or hail falls from the clouds onto Earth's surface. And then evaporation occurs when the liquid water changes back into a water vapor, which is a gas. And then condensation. This occurs when the water vapor cools and changes from a gas back to a liquid. And clouds form also by this process. And then, of course, runoff is the water, usually from the precipitation that falls, that flows across the land, collects in the rivers and streams, and then eventually ends up in the ocean. So let's talk for just a second about humidity. If you've ever gone outside in the summertime and it was so hot and not a breeze at all, and you just immediately break out into a sweat. Okay, that is due to the humidity. It's also called, it's like stifling. You can't hardly breathe. So humidity is the amount of water vapor that's actually in the air at a given time. The air's ability to hold water vapor changes as the temperature of the air changes. So warmer air or hot air can hold more water vapor than cooler air can. So the warmer the air is, the more water vapor it can hold, as you can see by this graph. Relative humidity is the amount of water vapor in the air compared to the maximum amount of water vapor that air can hold at a certain temperature. And we, of course, can calculate the relative humidity by using this equation. You don't have to memorize the equation. So how do we determine this? So we find the relative humidity by locating, if you'll look here, locate the column head that is equal to the difference between the wet bulb and the dry bulb readings. Don't get so bogged down in that it doesn't make sense. Bill Nye does a really good job of explaining it. And then you locate the row head that equals the temperature reading on the dry bulb thermometer. The value that lies where the column and row intersect, such as this, would equal the relative humidity. So this is, you use a psychrometer, that's a cool word, which is an instrument that's used to measure the relative humidity. And this is where you get into the 2 thermometers. a wet bulb or a dry bulb. And again, Bill and I will explain that a whole lot better. So the difference in temperature readings between the thermometers indicates the amount of water vapor that's in the air, henceforth giving you the relative humidity. Here is one more brain pop that you're going to watch on humidity and complete that quiz as well. And then last but not least, condensation. We're going to add dew point to this. We know that condensation is the process by which a gas, like water vapor, becomes a liquid. So the dew point is the temperature at which gas condenses back into a liquid. So it condenses, condensation. If you get up in the morning sometime and there's dew on the ground, that's due to, D-U-E, due to condensation. So the dew has fallen. This is the end of lesson 7.1a. The next time we pick up, we're going to continue with water in the air with lesson 7.1b.